Okay, this is term 2, week 6, term 3, sorry, week 6, chemistry CA. I'm gonna start quickly. What are always conserved in any nuclear reaction? No. What is always conserved in a nuclear reaction? Uh, you know, whenever we have the nuclear reactions like over uh, here, uh, you know that the mass here is always equal to the mass here, and the charges like on the left are always equal to the charges on the right. Yeah. So what does the mass represent? The mass represents protons plus neutrons. صح? Okay. So the protons are always conserved. The neutrons are always conserved. Also, what do we call protons and neutrons collectively? We call them nucleons. Okay. You can also say nucleons are conserved. Okay. And then this bottom part, what's it called? The bottom part is the charge, right? The number of protons. You could actually call it the charge. So also the charge is conserved. Uh, that's just explaining any question one. So know that always the charge, the nucleons, neutrons, and protons are conserved. Okay. Question two. What is true about the mass of the nucleus? Just memorize this. Okay, it was in the notes. The mass of the nucleus sometimes could be different from the sum of the mass of the nucleons. Okay. Just memorize this, I guess. Question three. What is chemical kinetics? It's a study of reaction rates. Very easy. Question four. Yeah. What is this particle? Obviously, it's positive, right? So it's a positron, not an electron. Obviously, the charge is +1, and the mass is not 0. Okay. If you put 0, you're gonna get it wrong. Okay. The mass of any beta particle, which are the electrons and the positrons, is negligible, not 0. Question 5, because they have a small mass. Nothing on Earth has a 0 mass. Okay, it has a small mass, but we just don't write the mass up here because it's 0.0000000, so they just call it negligible. Okay, which one here is an alpha particle? You all know it's helium. Okay. Question 6. Okay, this one is the famous question we get every week. Uh, I'm gonna do this a bit quicker. Just add up the bonds on the left, subtract by the bonds on the right. Okay, multiply. We have 4 CH bonds. Okay, I'm not gonna do it. I don't have a calculator beside me, so I'm just gonna write down what you have to do. And then you have a carbon double bond, so CC, so you add 6O2, right? And then plus we also have the ClCl, which is over here 240. Okay, I don't know what you get, blah blah blah. And then you subtract this by we have again 4 CH bonds. Okay, so 4 times 4, 13. بعدين عندك CCl 2 CCl bonds ف 2 times 327 plus 2 times 327. Okay, زائد ال C in the middle, CC, single CC. So plus 346. Okay, put this in a calculator, you get minus 158, and then put it to 4 significant figures. By the way, for the written today, for part, I think it was B or C for the second page, when they asked find the enthalpy change for per mole of CO2, if in your answer you did not write, let's say you got the answer correct, I think it was 550, okay, kilojoules. If you just put 550 kilojoules, you're gonna get wrong. So you have to say 550 kilojoules per mole. If you don't get this, you would have gotten minus 0.5. Okay, I'm saying this because I got it wrong. I just said, you know, a lot of people didn't put it. I thought that. Anyway, 203 203 to produce 302, NO plus O3 to produce whatever. We get this again every week. First thing, write down your reaction that you want. NO plus half O2 to produce NO2. Okay, first step with the NO2 on the product side and NO in the unit reactant side. So we just copy down this reaction. Okay, بتكتب NO plus O3 to produce NO2 plus O2. Okay, بعدين نحن بدنا we want to subtract something by this O2. نحط اكتب delta H. Delta H هي minus 122. We want to subtract something by this one to get 1 over 2 and many times. Because we did this question too many times, we know it's going to be 3 over 2, right? So we have to divide this reaction by 2. Also, we have to flip it, right? Because we want oxygen to be O2, we want it to be here. Let's flip it. It's going to become 3 over 2 O2 to produce 2 over 2 O3, which is just O3. 2 over 2 is 1. Okay, and since we flipped it, هتصير delta H positive, and we divide by 2, يعني positive 200 213.5. اوكي بعدين عندك ال O3 cancels with the O3 3 over 2 O2 minus 1 O2 gets you 1 over 2 O2, and then you're left with NO plus 1 over 2 O2 to produce NO2. And بعدين delta H, you just add negative 122 plus 213.5, and you're going to get 91.5 positive. Question 8. Okay. Okay. هن ما عطوك they didn't give this. Okay. They said rewrite it. فأكيد we have to add these up. We get 236. Add these up, you get 233. Okay. You add these up, you get 92. Add these up, you get 92. طيب. Okay. أول شيء we look at is whatever you want. The charges. Okay. The charge, no need to add, so it's just 0, right? So our molecule is going to have 0. Okay. Then here we have, if you subtract the masses, it's 3. So I need to add 3 over here. Okay. Is there anything with 0 and 3? أول شيء you have to look at, is there anything with 0 charge? And the only thing with 0 charge is the neutron, right? You know, neutron is 0, 1. Okay, but what's the problem? We need 3 mass, not 1. So what do? You just put the 3 in front. Okay, that means you're multiplying this neutron by 3, right? So you just write, like I wrote here, 3, 0, 1, and then n. Okay, question 9. 9. In general, okay, obviously if concentration decreases, the rate of reaction decreases. Hold on, I'm gonna go through them quicker. تاني واحدة, I think it was pressure. Temperature decreased, and the rate of reaction will decrease. Question 11, if the reaction rate of this reaction can be expressed as what? Okay, how can you, this also came in our periodic today. Okay, the most efficient way is always to measure the volume of the gas produced. But in the choices, they didn't put volume of CO2 produced, okay? They put volume of CO2 produced per mass, okay? Per mass. And that is not how we measure reaction rates. Reaction rates always have to have per time at the end. Since this choice had per mass, then that's wrong. Okay, the only thing that had per time and made sense was this. Okay, if they said H2O used per time, that would be wrong because it's in the products. Yeah, for products we measure, if we're measuring it in the products, and you have to measure how much of it is produced. Okay, since H2O is in the products, we see how much H2O is produced per time. Question 12. Okay, well, I'm gonna go through this fast. 9 plus 4, 13. Only have 12. What do? You have to add 1, right? So the value of A is 1. Then home 4 plus 2, 6. Heidi 6. Do they need to add? No. So Z is 0. Okay, which one has charge 0, mass 1? Obviously, it's a neutron, right? بعدين هون add them up. 15, home 14. So we need 1 here. 0, 7, home 6. What do I have to add? Here I have to add 1, right? So I have 1, 1. And what's 1, 1? That's a proton, right? So 1, 1 proton. Okay. Question 13. Okay, what is the charge of the missing element here? Very easy, 92 horn. Here you have 54, right? So 92 minus 54 is going to be 38. بعدين mass 236 horn. Okay, here you have 143. And here you have 3 times 1, which is 3. So here you have 146. So you do 236 minus 146, you get 90. Question 14. Okay, you just write down the reaction. Nitrogen monoxide, NO, reacts with oxygen gas, O2, to produce NO2. So أول شيء we have to balance it. Okay, NO plus O2 to produce NO2. How would I balance this? Okay, أول شيء I multiply this by 2. Since now I have 2 nitrogens here, I have to multiply this by 2. And then check the oxygens. Here you have 4. Wait. Yeah, here you have 4. Here you have 2, and here you have 2, so it's balanced. And then the state symbols, أكيد you guys write. I'm not gonna write them now. But they said releasing 56 kilojoules per mole of nitrogen monoxide. Here I have 2 moles of nitrogen monoxide. So what do? Times 2, and I get 112. The energy, where do I put it? Do I put it at the start or at the end? Since they said releasing, what do? We put it at the end, okay, because it's being released. So like, we put it here. And what's the unit? It's kg. Question 15. I think it starts with the old questions. Okay, this one very easy. Okay, hydrogen reaction. Okay, sample of 108 kg of aluminum is reacted. Okay, with excess. Excess doesn't mean we're doing limiting excess. No. The limiting excess is when they give you 2 numbers. المهم, to produce aluminum oxide, find the moles of aluminum. N equals M over M. Okay, so this is 108,000 because it's kilo. So 108,000 divided by molar mass of aluminum, which is 27, and you get 4,000. Okay, بعدين بدون oxygen, you just do RR and GR. You have, this is your reaction here. So you do RR, GR. you have 4 aluminum, it became 4000, right? هون I have 3 oxygen, so how much would be? أكيد if you cross multiply you get 3000. okay. question اللي بعد في part C. calculate the mass of oxygen. okay, إذا أنا عندي 3000 moles of oxygen N equals M over M, right? the moles 3000 equals the mass على molar mass. molar mass of oxygen هي O2 which is 32. they give you O is 16. ف you put 32 here, you cross multiply بيطلع لك 96,000. 1 2 3. اوكي بس هنا بدهم اياه kilograms, ف you divide by 1000 you get 96 kilograms. okay, this is in grams. okay, and then for significant figures put 0.00. question 16. okay, which is the heavier gas? Obviously the one that has a lower rate of diffusion, which is gas X. Find the molecular mass for gas X. Use V1 over V2 equals radical M2 over M1. I'm just going to substitute. I'm not going to solve it. V1, always put the lighter gas up. So 0.87 over 0.63 equals radical M2. M2 is the one for 0.63, which is gas X, over M1, which is hydrogen chloride. And hydrogen chloride is HCl, which is 36.5 if you add this. okay, so 36.5. okay, بعدين you have to square both sides. okay, then cross multiply. I'm not gonna do it, I don't have a calculator beside me, but you will get 69.6. this question been repeated many times. okay, order it from biggest to small, fastest to slowest. أكيد the slowest will be the heaviest and the fastest will be the lightest, because carbon dioxide is 44, HCl is 36.5 and H2O is 18. بعدين here أكيد it's gonna, what is this process called? Diffusion. Where will it meet? أكيد since they met closer to B, that means A is the faster one because it reached here before B reached. okay, question 17. okay, the concentration of ions. A solution is prepared by adding 50 cm cube of a solution called which contains Na2SO4 to 150 centimeter cube of solution contains 0.2 moles of the NCl2. Calculate concentration of all ions. If you remember my steps, أول شيء is write your dissociation reaction, right? Dissociation. okay, tiny step is to calculate moles. بعدين you just find you find the concentration C equals N over V. okay, أول شيء dissociation reaction for each one. أول شيء Na2SO4 Na2SO4. okay, this produces Na plus and SO4 2 minus. صح. Now let's balance it. You have 2 NAs, so you have to put here. okay, then our second dissociation reaction is ZnCl2. So let's write it ZnCl2 to produce Zn. Zinc is Zn2 plus or Cl minus, بس هيدي 2 here, so we have to put 2 Cl minus. مظبوط. اوكي هلا second step is the moles. هون عندنا 0.1 moles, فهون 0.1. since هيدا coefficient of it is 2 شو بيصير 0.2. بعدين هيدي coefficient of 1 is coefficient of SO4 is still 1, ف we keep it as 0.1. تمام. هون ZnCl2 قالوا لنا 0.2 moles. They said 0.2 moles, ف you write 0.2 moles. هون zinc same coefficient, فأكيد it will be 0.2. هيدي it's 2, ف you have to multiply by 2 you get 0.4. هلا شو بنعمل؟ C equals N over V. Very simple. But our volume is 50 plus 150, right? 50 plus 150, which is 200 centimeter cube. But we need the volume in dm cube. So this is 0.2 dm cube. To convert, you just divide by 1000. For each one, for Na, it's going to be the moles of Na, which we said is 0.2, divided by 0.2, which is the volume, right? This is the V total, 0.2 dm cube. Okay, which is 1. SO42 minus is 0.1 على 0.2. You get 0.5. Zn2 plus is 0.2 على 0.2. You get 1. Cl minus is 0.4 على 0.2, which is 2. Okay, easy. Question 18. Okay, what are the bonds? KCl is a metal with a non-metal, so ionic. NCl3, they're both non-metals, so أكيد covalent. And then N2 and N, they're both non-metals, فأكيد covalent. Thank you so much for watching and good luck.